This video accompanies a paper about a technique called GIvox for global illumination. In global illumination, light doesn't just come from a point or direction, it comes from entire surfaces. In this case, the ceiling is casting light down onto the walls. The walls reflect this light onto the other walls and the rest of the room. That's global illumination. In GIvox, any surface can cast light. In fact, there is no difference between surfaces that send light out, light sources, and surfaces that can receive light or cast shadows. They all just interact with light. In addition to the overhead light source, and the light bouncing off of the walls in the room, we have some little spotlights, as well as the red and white light coming through a teleporter on the left. The model we're looking at is a Quake 3 compatible BSP file from a GPL set of game content called OpenArena. As you can see, the model is pretty dark. Everything you see here was rendered in real time, at over 30 frames per second, without any pre-computation. Every frame, we render the light in the scene into a grid of 100 cubed voxels. That's 1,000,000 voxels. At each voxel, we store the light going in 6 different directions. What makes this affordable is we can store the voxels in a 3D texture on the graphics card, and we can compute a 2D layer of that texture based on just the previous layer and the new geometry that intersects the layer. I'm going to stop the camera and show you how these layers are computed. Here a bright red plane is passing directly overhead. Let's look at the voxels. Each layer of the voxel grid is storing a slice of the 3D scene geometry and the light inside of it. In each direction, here downward-facing light, we store a separate portion of the voxel grid. Downward traveling light from the plane spreads out as it heads downward. We can implement this with blurring. However, light travels in straight lines, but blurs don't. If we blur with a fixed size kernel, the dimensions of our blur have a sort of square root dependence on distance. We can fix this by increasing the blur kernel size with distance. On modern hardware, it's easy to compute the blur kernel size, and hence the blur filter taps, per pixel. This makes light spread out properly. Now that we have light spreading out properly, let's make sure it's reflecting properly. Here's the light in our voxel grid without any texture applied. Now, we're going to change the surface reflectance. Doubled, and now quadrupled. Now light's reflecting up from the floor and from the stairs on the right. And here we're varying the reflectance, even into non-physical values. Here's the same adjustment, now with the textures shown. GIvox really is computing global illumination. During these moving camera scenes, we're also moving the GIvox voxel grid. You can occasionally see jumping type artifacts caused by geometry moving in and out of a grid cell. For a small light source, sometimes it's the difference between being seen and not being seen. Notice how the small light sources on the left shimmer a lot more than the large light source up above. The shimmering can be reduced by computing small light sources using some other technique, and saving GIvox for the big light sources. The graphics hardware provides trilinear interpolation on our voxel grid light samples, which looks nice in smooth areas such as under the stairs, or near the corners in the ceiling. Thanks for listening to the video, and I hope you'll consider GIvox the next time you need to compute global illumination in real time.